So this is the 2-6 worksheet, homework worksheet key. So hopefully this will help if you have any questions or misconceptions about what you had to do to solve here. So in the first problem, understand that these are vertical angles. So in order to solve this, we're going to set the two expressions equal to one another. And then we're just going to solve this algebraically. So if we solve everything correctly, we should get x to be 28. The same is true in question 2. We're going to notice they're vertical angles. So we set the two expressions equal to each other. And when we solve this, you'll bring 2x over, you get x, bring 40 over, add it, you get x equals 30 is your total. Question 3 adds a step because now we have to deal with a y variable as well. Even though it tells us to solve for x, we're going to go and solve for y too. So in this case, you notice that the x variables here are vertical angles, so we'll take, so here we want to set the two expressions equal to each other. So we've got 10x minus 18 equals 8x plus 14. We'll bring the 8x over, and we'll get 2x. We'll bring the 18 over, and we'll get 32. When we divide by 2, x should be 16. To figure out what y is, all we need to do is plug in 16 for x into, let's say, this angle here. When we do that, we've got 10 times 16 is 160, minus 18 would be 142. Notice that these two angles here are a linear pair, so whatever 180 minus 142 is will give us y, and so in this case, y should be 38. Question 4, you should once again notice that you have vertical angles here and here, so we're going to set the two expressions equal to each other, and we're going to solve for x. You'll subtract over 4x, you'll get 3x. Add over the 27, and you should get 39. In this case, x equals 13. For question 5, same idea. You got vertical angles here and here. So that gives us 3x plus 2 equals 6x minus 118. Subtract 3x over, you get 3x. Add over the 118, you get 120. In this case, x should be 40. And then in the last one, you have options here. You can either use vertical angles here and here, or a linear pair. And so just to mix things up, I'm going to go linear pair on this. I'll say 9x plus 2, or 9x plus 2 plus 3x plus 10 equals 180. Combine my like terms, I get 12x plus 12 equals 180. I'll subtract the 12. 12x equals 168. Divide by 12 in this case, and you should get 14. X equals 14 in this case. Question 7. Angle A is 21 less than twice as large as its supplement angle B. So what this means, let's say that the supplement B is x, and we're trying to find A. Well, twice as large would be 2x, but 21 less. And so supplement means 180. So what we're doing is we're setting up 2x minus 21 plus x, so we're adding the two angles together, equals 180. And this is what we want to solve. And when we combine like terms, we get 3x minus 21 equals 180. And we solve, we should get x to be 67. So that means B, angle B, equals 67. And angle A has to be, in this case, 113. Question 8, same idea. Angle A is 18 more than 5 times its complement. Well, complement means 90. So in this case, let's let B be x. 18 more than 5 times its complement, so 5x plus 18. And now we just want to set this up. So we'll take 5x plus 18 plus x equals 90. Combine like terms, you're going to get 6x plus 18 equals 90. When you solve that, you get x equals 12. So that means that angle A equals 78. and angle B equals 12. Question 10, our proof. They give us that angle A is congruent to angle BDA, and they ask us to prove that X is 5. So most proofs start with a given statement, so we're going to restate the given here in step 1. A is congruent to angle BDA. From there, they talk about vertical angles are congruent. Well, the vertical angles of relevance here are probably going to be CDE and BDA. So we're going to say angle BDA is congruent to angle CDE. From there, they tell us that angle A is congruent to angle CDE because they've taken what A equals here, and they've substituted A in for it in the other problem. So they've substituted here. This is substitution. Notice that A, you could say substitution, or you could even say transitive property here, because if you look carefully, both angle A and CDE are both congruent to BDA, so that would also be the transitive property. So you can also say transitive property. From there, they talk about congruence here. And this one's a little trickier. We don't normally include this in some of our proofs, but all they're doing is telling you that the measure of angle A equals the measure of angle CDE. All right, so that's what they're getting at. They're saying, hey, they're congruent, but their measures are the same. Well, that's the definition of being congruent. From there, they plug in each expression that represents each angle. So once again, this is substitution. Then they clearly subtract the 11x over. So you've got 20 equals x plus 15. Then they're subtracting over the 15. So you get x equals 5. We've given that angle 5 is congruent to angle 2, and we want to prove that angle 4 is congruent to angle 8. So first step, we restate the given. So angle 5 congruent to angle 2. From there, they say 2 is congruent to 4. Well, I know that because they're vertical angles, so VAT. Then they say transitive property. Well, that must come from the fact that both 5 and 4 are congruent to angle 2. So they must talk about that here. So angle 5 is congruent to angle 4 by the transitive property. And we're trying to prove 8 and 4 are congruent. So in the next step, I think they're going to make a comparison between angle 5 and angle 8. Well, they're vertical angles, so I can use that here. Angle 5 is congruent to angle 8. And then once again, I notice that 4 and 8 are congruent to the same angle. So I can say that 8 and 4 are congruent, and I can say that through the transitive property. Question 12, they tell us that 1 and 2 are complementary, 2 and 3 are complementary, and that BD bisects ABC. We want to prove the measure of angle 1 is 45. So first step, they've restated the given. That's clear here. Then they talk about 2 and 3 being complementary. Well, they talk about it, but then they tell us they add up to be 90. Well, they're just telling us the definition of complementary here, or they're using the definition of complementary. Because we're told at the beginning that they're complementary, but what does that really mean? Well, it means that those two angles add up to be 90. The hint in question 3 tells us definition of angle bisector. Well, which angles were they talking about being bisected? Well, BD bisects ABC. So that must mean that they're talking about here that ABD must be congruent to DBC because those are the two angles created by the angle bisector. Well, if you look carefully, instead of using the names there, we could have also used the numbers. So let's go back a step. Instead of ABD and DBC, we can use angles 2 and angle 3. Okay, so this fits the proof better. Now that we've done that, what they're doing is they're saying angle 2 is equal to angle 3. So they're substituting angle 3 in for angle 2 in this step here. So here we're just dealing with substitution. And that's how they get this step here. And then, since they know 3 plus 3 equals 90, you can easily say 2 times the measure of angle 3 equals 90. Well, if you're undoing this step to get here, clearly they've divided, or they've used the division property. Now, if we go back to the very beginning and where we talked about 1 and 2 being complementary and 2 and 3 being complementary, we should notice that both angles 1 and angles 3 are complementary to the same angle, which makes them congruent. And if they're using the congruent complements theorem, this is probably where they're illustrating that. So the measure of angle 1 should be equal to the measure of angle 3 by the congruent complements theorem. Now that we have this statement done, we're going to take the fact that angle 3 equals 45, and we're going to replace that information, that the measure of angle 3, in the second statement here. So we're going to replace this statement with the fact that it equals 45 in order to get this. So the very last step of this proof is just substitution. Last question, it says if APB and CPD are vertical angles and APB and APE are complementary and CPD and CPF are complementary, then APE and CPF are vertical angles. We want to prove or disprove the following statement. So ideally, all you're trying to do here is draw an example where you could either prove or disprove this. And in reality, this isn't necessarily true. You can draw it to where this isn't true. Let's see if I can draw an example. Let's see. So they tell us APB and CPD are vertical angles. Okay, so let's start there. We'll say A, P, D, and then we'll say C, let's go through there, P, B. All right, so those are vertical angles, so that takes care of that. APB and APE are complementary, so let's put that there. Let's put E here, and we'll say this here. CPD and CPF are complementary as well. So we need to create that. So let's put that here. We'll say this is a right angle. Therefore, APE, so APE and CPF are vertical angles. Well, no, they're not. So we managed to disprove it by drawing our diagram like this. We've met all the criteria, but this isn't a true statement in the end.